Let's now study the solubility of magnesium hydroxide in two separate solutions. The first one is your magnesium chloride. The second one is sodium hydroxide. And in the case of magnesium chloride, there is a common ion between MgCl2 and magnesium hydroxide, which is none other than your Mg2+. So it means that even before magnesium hydroxide could be dissolved, some of the seeds are already taken up by your Mg2+. As a result of magnesium chloride dissolving in the water and releasing its Mg2+ ions. So hence, there will be fewer seeds available for magnesium hydroxides to occupy. Hence, the solubility of magnesium hydroxide would decrease. Similarly, in the same vein, when magnesium hydroxide dissolves in sodium hydroxide, the common ion is OH-. So it means that even before magnesium hydroxide could dissolve, some of the seeds has already been occupied by OH- as a result of sodium hydroxide dissolving in water. So it means that there are also fewer seeds now available for magnesium hydroxides to occupy in the theater. Therefore, the solubility of magnesium hydroxide would also reduce. Hence, in conclusion, a common ion effect will lead to lower solubility of the insoluble salt. Now let us take a look at the mathematical calculations for the solubility of magnesium hydroxide when we have to factor in the common ion effect. So in the case of magnesium chloride, assuming magnesium chloride has a concentration of 0.1 mole per dm cube, it means in the KSP theater, there's already 0.1 mole per dm cube of Mg2+. Hence, when you actually finalize the concentration of Mg2+, it will be 0.1 mole per dm cube plus Y. Y is the concentration of Mg2+ that is released as a result of the dissolution of your magnesium hydroxide. And concentration of OH- remains as 2Y. The key assumption that we need to make is that 0.1 mole per dm cube of the Mg2+ found in the solution as a result of the dissolution of magnesium chloride is significantly larger than the concentration of Mg2+ found as a result of the dissolution of magnesium hydroxide. After all, magnesium hydroxide is an insoluble salt. So because of this assumption, we can estimate 0.1 plus Y to be just 0.1. And from there, we can find the value of Y and we can validate the assumption to be true. So that is the value of the solubility of magnesium hydroxide in magnesium chloride. We'll now do likewise if we were to dissolve magnesium hydroxide in 0.1 mole per dm cube of sodium hydroxide. In the same way, concentration of OH- is now 0.1 mole per dm cube inside the KSP theater, which means the concentration of OH- in the KSP expression should be 2Y plus 0.1. And we will also make the assumption that the concentration of the Mg2+ as a result of dissolving sodium hydroxide is significantly higher than the concentration of OH- produced as a result of the dissolution of magnesium hydroxide. With the assumption, the 2Y plus 0.1 will be pared down to 0.1. And with that, we can find the value of Y, which also further validate our assumption. So hence, from the calculations, we can conclude that magnesium hydroxide is less soluble in sodium hydroxide.